Welcome to DA420 Week 2. This is Charlene Cheng. In this video, we will mainly talk about conjoint analysis. Conjoint analysis is a survey-based statistical technique used in market research that helps determine how people value different attributes, feature, function, benefits that make up an individual product or service. A linear model fit to preference rankings is an example of traditional conjoint analysis. The example of conjoint analysis in the book is preference data for mobile communication services. It took market survey of 4 different brands: AT&T, T-Mobile, United States Cellular, and Verizon. In the survey, it covered 7 different aspects: startup cost, monthly fee, what kind of service it provides, retail or not, Apple or not, Samsung or not, Google or not. After the survey, it generalized a table of preference data for mobile communication services, which cover the 7 different aspects along with 4 different brands. Please note at the end there's a ranking. The ranking is the task that we're gonna use the 7 different aspects to do prediction on the task, which is the ranking. To set up this kind of analysis, firstly, we will use some contrasts. Generally speaking, when doing conjoint analysis, we utilize some contrasts. The sum of the fitted regression coefficients across the levels of each attribute is 0. So here is the example. When we use the traditional contrast, we might set up the control equals to or 0, while the A for the attribute 1 is 1, the B for attribute 2 is 1, the C for attribute 3 is 1. However, when we utilize some contrast, note that the control for all 3 attributes are -1. In this case, the sum of each level across each attribute is 0. Part work. The fitted regression coefficients represent conjoint measurements of utility called part worth. And spine chart. To display the results of a conjoint analysis, we use a special type of dot plot called the spine chart. Here is the very quick and short example. You can also look at the table 3, the figure 3.1. That is the full spine chart for this analysis. In a spine chart, part worth can be displayed on a common standardized scale across attributes. The vertical line here in the center is anchored at 0. The part worth of each level of each attribute is displayed as a dot with a connecting horizontal line extending from the spine. The preferred product or service characteristics have positive part worth and fall to the right of the spine. Less preferred product or service characteristics fall to the left of the spine. The spine chart shows the standardized part worths and attribute important values. The relative importance of attributes in a conjoint analysis is defined using the ranges of part worths within attributes. These importance values are scaled so that the sum across all the attributes is 100%. So what does the spine chart say about this consumer's preference? If you look at the figure 3.1, it shows that the monthly cost is considerable importance. Next in order of importance is 4G availability. The setup cost is much less important than monthly cost because the setup cost is just a one-time cost. And the consumer ranks the four service providers about equally. Having a nearby retail store is not an advantage. So this is pretty much about the spine charts and about the conjoint analysis. Setting up the problem. Predictive analytics processing steps, CRISP-CM. That means cross-industry standard process model for data mining. It describes the data mining process in 6 steps shown below. First, understand the business. Second, data understanding. Third, data preparation. Fourth, modeling. Fifth, evaluation. Last, deployment. For program managers, the CRISP-DM describes the steps in the modeling process from a program perspective. Reviewing the steps analysis will be completion as they build predictive models. For practitioners, the step-by-step process provides structure for analysis and not only reminds of analysts of steps that need to be accomplished, but also the need for documentation and reporting throughout the process, which is particularly valuable for new modelers. Look at the business understanding. There are 3 legs of the stool. First is domain experts. They are needed to frame a problem properly in a way that will provide value to the organization. Secondly, data or database experts, which help identify what kind of data is available for predictive modeling and how that data can be accessed and normalized. The third is the modeling experts. The modelers are needed to build up the models that achieve business objectives. The data understanding. At the core of data understanding stage is using summary statistics and data visualization to gain insights into what data you have available for modeling. And the following feedback loops in this figure indicates the most common ways the physical process is modified based on finding during the project. The very first is business understanding, and second is data understanding. We usually go back and forth between those 2 steps. And then data preparation, modeling. Again, we go back and forth between data preparation and modeling. Evaluation. Remember, we use the training test regimen when doing the test and the training. Test is the evaluation step. If the evaluation is good, we're gonna go to the deployment. Otherwise, we go back to the business understanding and start from the very beginning one more time until the evaluation is satisfied.